Hey everyone, Mr. Ahmed here. I thought I'd make this video to go over what you guys need to know in the percentages unit to do well on your upcoming percentages unit test. So there are 4 key things that you need to know for the unit test. The first thing is how to calculate percentage change. The second thing is how to calculate the initial price if we give you the percentage change and the final price. You need to know what compound percentages are. And then finally, you need to know how to convert between fractions, decimals, and percentages. So I'll go over each one of these in this video. So for the first thing that you got to know how to do is how to calculate percentage change. Now you'll think back to the very first thing that we saw this unit was this little formula right here, where you're going to take the new value, you're going to subtract it by the original value, and then you're going to divide by the original value. You take this and you multiply it by 100%, and that gives you your percentage change. So I've got an example over here. So a car dealership sold 200 cars in 2022, and then in 2023 they sold 240 cars. So if I read this correctly, right, I can kind of deduce that, well, this is my original number, right? My initial number was 200, and my new number is 240. Okay, so to calculate the percentage change, I'm going to have to go and say, well, 240, which is my new value, minus my original value, so that was 200, divided by my original value, which is 200. And then that times 100%. Okay. Well, based on that, I see that I've got 40 over 200. Okay, so for 40 over 200, which really simplifies down to 4 over 20, right? But we know that that even simplifies even further down into 2 over 10. Okay, and 2 over 10 as a decimal is 0.2. Okay. And then 0.2, if I want to multiply it by 100%, that means I'm just taking this decimal value and expressing it as a percentage. So 0.2 times 100, well, that gets me 20%. Okay, so this is a 20% increase from 200, and that kind of makes sense, right? If I look at 200 cars and I say, okay, if I increase this value by 20%, well, I know that 10% of 200 is, that's right, 20, right? So 10% is 20 cars, and therefore 20%, which is double, is 40 cars. So an increase of 20% should correspond to an increase of 40 cars, which is the case here, okay? So that's the first thing that you need to know for the unit test. Obviously, you're not going to have an example like this one on the unit test, but you know, if you can kind of do this sort of example, you'll be good for this. Now, the next thing you need to know is how to calculate an initial price if you're given a percentage change and a final price. Okay. Now, we saw that there were a couple of different ways to do that, right? We saw mainly two different ways to do that. The first way is to think about the original price and attribute, a variable to it, right? And say, okay, well, what was the original price of the necklace? All right, so I'm going to say that that's Z, for example. Okay, and then here you've got Anita bought a necklace for $260 that was marked up by 30%. What was the original price of the necklace? So you have to think about kind of like, how can you translate this backwards, right? You gotta think about, okay, what does this translate into? Well, backwards, it means that I've got an original price and I increased that original price by 30%, and I should get 260, right? Now, if you increase an original price by 30%, that means that your original price, which was originally 100%, right, is now increasing by 30%, and therefore is increasing to a value that is 130% of the original value. So that's kind of where I clue in, and I'm like, oh, okay, so I take the original value, and I'm going to multiply it by 130%, but as a decimal, right? So 1.3, and that should get me the new value, which is the value that we bought this at, right? Or that Anita bought this necklace at, which is 260. Okay. Now, when I've got something like this, what I can do is I can actually maybe convert this guy into a percentage, right? So, or sorry, a fraction. Now, this guy right here is technically 130, or 13 over 10, as you please, or also 130 over 100, right? Convert that into a fraction, 130 over 100. And that's equal to 260. Okay, again, you could have converted that into 13 over 10 and that would work just as well. Okay. Then my next step is going to be to divide by 130 over 100, right? Because you want to isolate for z. So here you're going to say, well, z equals 260 divided by 130 over 100. Okay. And we know that we can change this division into a multiplication, right? By flipping this fraction right here, right? By taking its reciprocal, right? So you're going to say 260 times 100 over 130. Okay, well, based on this, I know that 260 actually is double of 130, right? So 260 is actually 2 times 130. So that leaves, so for example, if I were to separate this guy into 2 times 130, then I can cancel out the 130s, right? And I'd end up with just 2. You can also just think of it as, well, what's 260 over 130? Well, that's just 2. Okay, so that's 2 times 100, which is 200. Okay, now that's the first way that we saw how to do this. The second way that we saw how to do this was just using proportions and really just using proportional reasoning to set up a proportion that you can then cross multiply and solve for z. Okay, now here we have to understand that this price right here has been marked up by 30%. That means if I were to compare, if I was to consider the original price as 100%, then this new price is 30% more than 100%. That means this new price is 130%. Okay, so that's kind of the reasoning that I've got to do at the start before I set up my proportion. Okay, so there you go. I can actually set up my proportion by saying, well, $260 is 130%. Therefore, what value, and that's where we use Z, that original price, is 100%. Again, the original price is that unknown, it's Z, and that original price, we have to consider it as 100%. Okay? And when you do cross multiplication on this, you actually end up getting the same thing that you get over here, right? You're going to go diagonally first. Okay, when you do cross multiplying, you go diagonally first by multiplying. So you're going to say 260 times 100. And then you're going to divide by 130. So when you go across like that, you're going to divide. Okay? So again, going diagonally is multiplying, and then going across is going to be dividing. Okay? So this is 260 times 100, and then divided by 130. And you know what? Guess what? It's the same thing as this right here, right? You end up getting the same value. Okay? All right, so that's that second bit that you needed to know, which was how to calculate initial prices if we give you the percentage change and the final price. The next thing that you need to know is compound percentages. Now, compound percentages are just when you apply a percentage change to an original value and you get a new value, and you take this new value and you apply another percentage change. Okay? So it's really just applying two percentage changes. Okay? You have initial value A, for example. Okay? You apply a percentage change to it and you get value B, and then you take value B and you apply another percentage change to it, and you get value C. Okay, that's what compound percentages are. Okay, so let's take a look at this example right here. You've got a collector's baseball card originally costing $50. The card's value increases by 30% in a year. Okay, so it increases by 30% in a year. Now, here you're going to say, okay, well, that's just, 50. And now I want 30% more than 50. That means as a percentage, I want to know what is 130%, right? So here you're going to say, well, 50 times 1.3, okay? And then you're going to get your answer there. Now, if you really think about it, you don't actually need to do any calculations for this. You can kind of even just using mental math, you should be able to do this, right? Well, just think about what's 10% of $50, right? Well, 10% of $50 is, 5. Well, 30% is 3 times that, right? 30% is 3 times 10%. So if 10% is $5, then what's 30%? Well, it's 3 times $5, which is 15. Okay, so $15. So I know that if I increase the card's value by 30%, I've got $15 more. The value is now $15 more. Well, $15 more than 50 is $65. Okay? So here, this guy right here is actually value B, right? We just applied a percentage change to this initial value, which technically was value A, and we got value B. Now, you take value B, you consider it as now the initial price, or the initial value, and then you apply the second percentage change to it. Okay, so I'm going to say 65 times, now this is decreasing by 40% the year after. What is the card's final value? Okay, well, if it's decreasing by 40%, that means that what I originally considered to be 100%, which is 65, has now gone down by 40%. And therefore, if I think about it in terms of percentage, the percentage that still remains is 60%. So that means I have to take 65 and figure out what is 60% of it. That means I have to multiply it by 0.6. Okay, well, I can actually just kind of reason this out as well, right? I've gone down 40%. Okay, well, you know what? Let's first of all figure out what is 10% of 65. Well, 10% of 65 is going to be 6.5, right? Which then logically means that 20%, which is double, 20% would be double 6.5. Okay, well, if I know that 10% is 6.5, right? Then that means that 20% is going to be 13, right? It's going to be double of 6.5, which therefore means that 40%, right? 40% is going to be 26, right? Double of 20, right? Okay, so that means my value, which was 65, has now decreased by $26. Okay, so if I were to do that, well, 65 minus 26, well, that's just 39. Okay. Okay, so there you go. That's what compound percentages are. Okay. Now again, you can use a whole different, way of doing these calculations. You could have changed these into fractions, right? Like this could have been 13 over 10, right? And then you'd cancel out the 10 in the numerator with, 10 times 5 up here. So you're going to cancel out 10 up here with a 10 in the numerator, right? And then you're going to get 5 times 13. Well, 5 times 13 is 65, right? You could have done the same kind of steps over here as well, okay? So again, there are different ways that you can kind of solve this stuff out. You can kind of use this sort of reasoning process, or you can just literally just do the actual calculations and convert these guys into fractions and then try to see if you can cancel out some factors, okay? Okay, and that's compound percentages. And for the very last thing, and probably the easiest one of these things is, or these concepts, it's just knowing how to convert between fractions, decimals, and percentages, okay? Now, if you have a decimal and you want to convert it into its percentage equivalent, remember that you have to multiply by 100, okay? So 0.5 as a percentage is going to be, 50%. Now, obviously, I'm not going to go do all these ones all over again because we already did these in class together. But again, to go from decimal to percentage, you're multiplying by 100. So this guy right here would be 18%. That one would be 34%. That guy would be 4%. Okay? Remember again that when you multiply by 100, your decimal point moves to the right twice, right? So here it's going to move to the right twice, and then you get 18. Here it's going to move to the right twice, and you're going to get 34, right? Okay, now to go backwards, then obviously, to go from percentage to decimal, you're dividing by 100, right? So you're going to be dividing by 100 to go backwards. Okay, that sort of makes sense, right? So 5%, if I were to divide that by 100, right? My decimal is now going to move to the left twice, right? Because I'm dividing by 100. Remember how I was multiplying by 100 and it moved to the right twice? Well, guess what? If you're dividing by 100, it's moving to the left twice, right? So this guy's going to be 0.05, okay? That decimal point was originally after the 5, right? It was originally here. And so when you move it to the left twice, well, you've got 1, 2. So you've got 2 jumps to the left. Okay, this guy right here, the decimal point is right here, right? It's 20.0, right? You don't see the decimal point, but it is there. It's 20.000, right? Well, that decimal point is going to move to the left twice. So you're going to go to 0.2, okay? And now, finally, well, actually, no, maybe not finally, but how do you express percentages as a fraction? The easiest way to do that is going to be to take that percentage, which technically is a fraction. It's actually in the word percentage, right? This tells you that it's 50% per 100. That means 50 over 100, right? So the easiest way to do that, to convert from percentage to fraction, is to just maybe like think about, 50%, just think of it as 50 over 100, right? And then from there, you can probably just look at that and be like, well, you know what? I'm going to divide top and bottom by 50. Well, that's just 1 over 2, right? This 5%, that's 5 per 100. That means 5 out of 100, okay? Well, that, when you divide top and bottom by 5, well, you're going to get 1 over, well, 20, right? 20%, right? That's going to be 20 over 100. Well, if you want to simplify this, you divide top and bottom by 20, right? Well, 20 divided by 20 is 1, and 100 divided by 20 is 5. So 20% is 1 over 5 as a fraction, okay? And, well, I think, you know what? That's technically it, right? If you want to convert from a fraction to a decimal, it might be easier to convert to a percentage first, right? And then convert that into a decimal, right? Express this fraction as something over 100, get that as a percentage, and then once you have it as a percentage, it's really quick to go into a decimal, right? Like 1 over 4 expressed as something over 100, well, that's, 4 times 25, 1 times 25, right? 4 times 25 gets me to 100. 1 times 25 makes this 25. Okay, so this is 25%. Oh, well, 25%, well, that's easy. That's just 0.25, right? So there you go, right? Same thing for this guy, 6 out of 25. Okay, well, multiply top and bottom by 4, right? You want to multiply top and bottom by 4 so that you're getting that denominator over, you're getting 100 as a denominator, right? So times 4 gets you 100. 6 times 4 gets you, 24. Well, that's 24%. That means this guy right here is 24%, which means this decimal right here is just going to be 0.24. Okay, and I think that's where I stop there. Hopefully that was helpful, guys. As long as you know how to do these four concepts, or sorry, as long as you understand these four concepts, you're going to be just okay. You're going to be more than okay for your unit test. All right, have a great evening, everyone.